Welcome to the chapter on mathematics for civil engineers. Mathematics is a fundamental tool for civil engineers, aiding in the analysis, design, and construction of infrastructure projects. This chapter covers essential mathematical concepts that first-year civil engineering students need to understand. In this chapter, we will cover solving equations, trigonometry, and calculus. These mathematical concepts are crucial for civil engineers in their daily tasks. Equations are mathematical statements that assert the equality of two expressions. Solving equations is a critical skill for civil engineers as it allows them to determine unknown values in various engineering problems. A linear equation is an equation of the first degree, meaning it has no exponents greater than 1. The general form of a linear equation in one variable is a x plus b equals 0, where a and b are constants, and x is the variable. Let's solve the equation 3x plus 6 equals 0. First, subtract 6 from both sides to get 3x equals negative 6. Then divide both sides by 3 to find x equals negative 2. A quadratic equation is a second-degree polynomial equation in one variable. The general form is x squared plus bx plus c equals 0, where a, b, and c are constants. The solutions to a quadratic equation can be found using the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's solve the quadratic equation 2x squared minus 4x minus 6 equals 0. Here a equals 2, b equals negative 4, and c equals negative 6. Using the quadratic formula, we get x equals negative 4 plus or minus the square root of negative 4 squared minus 4 times 2 times negative 6, all divided by 2 times 2. Simplifying, we get x equals 4 plus or minus the square root of 16 plus 48 divided by 4. This further simplifies to x equals 4 plus or minus the square root of 64 divided by 4. Finally, we get two solutions, x equals 3 and x equals negative 1. Trigonometry is the study of relationships between the angles and sides of triangles. It is especially useful in civil engineering for tasks such as surveying, structural analysis, and determining forces in structures. The primary trigonometric functions are sine, cosine, and tangent. These functions relate the angles of a right triangle to the lengths of its sides. For a right triangle with an angle theta, sine of theta is equal to the length of the opposite side divided by the length of the hypotenuse. Cosine of theta is equal to the length of the adjacent side divided by the length of the hypotenuse. Tangent of theta is equal to the length of the opposite side divided by the length of the adjacent side. Suppose you need to find the height of a building. You stand 50 meters away from the building and measure the angle of elevation to the top of the building to be 30 degrees. Let h be the height of the building. Using the tangent function, we have tangent of 30 degrees equals h divided by 50. We know that tangent of 30 degrees is 1 divided by the square root of 3. Therefore, h equals 50 times 1 divided by the square root of 3, which is approximately 28.87 meters. Calculus is the branch of mathematics that deals with continuous change. It is divided into two main parts, differential calculus and integral calculus. Both are essential for civil engineers in analyzing and designing systems. Differential calculus focuses on the concept of the derivative, which represents the rate of change of a function. Let's find the derivative of the function f of x equals 3x squared plus 2x plus 1. The derivative of f of x with respect to x is found by differentiating each term. The derivative of 3x squared is 6x, the derivative of 2x is 2, and the derivative of 1 is 0. Therefore, f prime of x equals 6x plus 2. Integral calculus is concerned with the concept of the integral, which represents the accumulation of quantities. The definite integral of a function over an interval gives the area under the curve of the function. Let's find the definite integral of the function f of x equals 3x squared from x equals 0 to x equals 2. The definite integral is given by the integral from 0 to 2 of 3x squared dx. To solve this, we first find the antiderivative of 3x squared, which is x cubed. Now we evaluate the antiderivative at the bounds. This gives us 2 cubed minus 0 cubed, which is 8 minus 0 equaling 8. So, the area under the curve from x equals 0 to x equals 2 is 8. Understanding and applying these mathematical concepts is crucial for civil engineers. Solving equations helps in determining unknown values. Trigonometry aids in analyzing angles and distances, and calculus is essential for understanding changes and accumulations in engineering systems. Mastery of these topics will provide a solid foundation for more advanced studies in civil engineering.